Hello and welcome to another Q&A video. I have thankfully managed to avoid the questions piling up to a giant level this time, so this will actually be a much shorter one. And I'll try and make sure I do these a little bit more regularly when ones come in, just because I don't want there being a giant wait for folks to have questions that they're interested in knowing the answer to. So let's dive on in. So one of the questions from Peter was about how to approach navigating in a dynamic 3D world. So this is sort of where we're talking things like Minecraft obviously has that. The world itself can change, areas can be open and closed. Deep Rock Galactic has that as well. So anything where you can sort of modify the structure of the world has to wrangle this. And that introduces quite a few sort of big challenges. We have the problem that we can't pre-generate much or potentially any of the path data. It's one of the downsides with procedural generation is it's not just generating the world. If you've got AIs interacting in it, which is pretty common, those AIs need to have data generated to facilitate them working typically. You can make AIs work without that data, but that is a significant challenge. There are methods for doing it, but yeah, it's a big, big challenge. So that means we might need to take time for generating that data. It also means that that data can actually change. So, as I said, paths will be getting opened, other ones might be getting blocked. That could happen while an AI is moving through an area. So it could already have picked a tunnel to be heading through, and then suddenly that tunnel is closed. Or it could have an area that it's trying to get to, and now there's a new shortcut that it could use. So the Unity NavMesh stuff does actually support rebuilding it at runtime. So for something that is moving along the ground, along the surface there, that is actually an option. Now, the rebuilding is not cheap, so what I would recommend is that you divide your world up into sort of zones or volumes, and when one of them is changed, you just rebuild that. So that minimizes the performance hit, also allows you to have the AI check, okay, does your path go through here? Yes, okay, you need to regenerate that path. Now, it might be able to just do a stitching either side of it, essentially eliminate the chunk of the path inside that volume, or it may need to do a full repath. But it is a big challenge, but it generally comes down to detecting things have happened, regenerating path data, and also then going and notifying the AIs so they know to repath. And if you've got the little volumes, you can do those things in the background. You can let the AIs, like I said. So it does require infrastructure to be set up. It's not something that out of the box is going to work with Unity NavMesh, but it is something that is an option there. And other question that was asked there from Peter as well, I believe, was about machine learning in games. And this is a really interesting one because you have seen some actual great uses of it, and even actually going back a very long way. There's been some quite good uses of it. So the drivatars in Forza made use of it. So these avatars that were driving, they were trained to be driving based upon how people were driving in the game. So those were an early use of machine learning. And there are toolkits out there. Unity has a machine learning agents toolkit, and they give you the tools to be able to train an agent, which you then use that in the game. So a lot of the ones will not do what would be referred to as online training. So where they actually train in the live game, they're usually trained offline, and then they are actually, that model that is trained is imported into the game. So the challenge with machine learning ones in particular versus a lot of other AI methods is debugging them. So state machines, behavior trees, GOAP, things like that, even in stuff like expert systems, it's very easy to see where it's going wrong and why. Like you can look at a visual of a behavior tree, you can look at a state machine, you can debug into the code, and you can directly see there, here is what I am trying to do. There's usually comments. So you've got a lot of detail there for debugging them. But machine learning doesn't work like that because it's a learning system. You have some form of neural network there usually that's been trained. And a neural network doesn't give you, specific line of code that says, oh, okay, I'm trying to do, this particular thing. I'm trying to move this way or steer this way. It's a set of weights and things like that are stored in it. So it can't tell you why it's doing the wrong thing. So there's no line of code to go and fix. And so they can learn bad or incorrect patterns. And it's kind of the nature actually of learning. We see that with ourselves, we see that with animals. We learn, can learn incorrect things. Or, and a lot of that comes down to how we are trained. So example I like to use with this is when I was growing up, Beagle that we had, we taught her, various things like sit and lie down, and providing a reward with each one. And so we taught her sit first, and she'd get a treat. And then with lay down, what we would do is we'd first usually get her to sit and then get her to lie down. And so she'd get a treat with each one. What she ended up doing was if you told her to sit, odds were she'd lie down, figuring, well, this is the quickest path to get 2 treats. And that's the thing. It was, not necessarily a wrong pattern because it achieved the goal that she was after, which was more treats. But it wasn't matching sort of what we were, what the instruction was. But can't fault her for wanting to get more treats. But this is the thing, machine learning, we can train it and it can learn bad patterns. And that's very difficult to debug because you can't really go and actually fix that. You either need to retrain it or have a better set of training data. So kind of general good practice with this is you have a set of training data, and then you have that you use for the building the neural network that gets used, and then you have a separate set of data that you use for evaluating it. So you keep those 2 data pools separate so that you can properly evaluate it. And that testing data set should really, really sort of stress test it in a variety of scenarios. But that separation is important, and having good training data. So good training data should, provide sort of a breadth of examples so it can try and learn a generalized thing. Because this is the other thing. Your machine learning, there's a difference between learning and memorizing. And things can end up become something where it's memorized a pattern, not actually learnt it. And the difference between those two is something that's memorized, when it is given that same sort of input, it can then reproduce the good output. But if it's given something different, it then could give a very bad output because it doesn't understand it. It doesn't match what it's memorized. Whereas something that is learned has learned how to respond in a generalized way. So if it gets something that is out of its expectations, it can still try and provide a reasonable response. That's what, most things that learn are actually doing. That's the ideal sort of setup there with learning. And that's why good data matters. So these can be a really effective solution. And in particular, great for when you have something where it has an example of how it should behave, or it can be given a means to assess performance. So with something like the Drivatars, it had data from other people playing it that it could then use as essentially, okay, let's provide this input, let's see what we get. compare it against what did happen. You could also get idealized data of, we know what the optimal path, optimal time could be for a race, and it could feed that back in. That gets a bit more complicated with stuff where it is very, very, very open-ended. So if you take something like in a combat game, assessing performance there is a lot more difficult. You have metrics there in terms of health and how it's moving. It's got a lot more freedom. So it's a lot more difficult if you've got something where it's full sort of open combat happening there. Not to say that the car example is a trivial one. It's very much not, but it is something that is a much sort of more conducive setup really for using something like machine learning. So it is a thing where it can be a really good solution, and you can get some really good results with it, but training takes time. Training something well takes even longer, and having that be something that is reliable enough where it doesn't have bugs is very difficult. And that's one of the things with the drivatars there. The achievement is not just the machine learning usage for them, but having something that is working quite robustly. That is a huge, huge achievement there with that. So, other one question that does come up a lot, and this is very much my fault that it comes up a lot, is with the GOAP. I did the goal-oriented action planning. I did a video where I focused on a monolithic approach, and I mentioned that I was going to do a video on the microlithic one, and I think this has now been over a year, probably more than that actually, since that video. So, as I said, long time ago, I talked about both. And the microlithic one has not yet appeared. Now, I have actually built the microlithic version quite a few times. I've tried a few different implementations, looked at other approaches people have used, implemented various ones that have worked. And I've kept all of those, but none of them have ended up making it into a video. And the main reason for that is every time I get them implemented, when I look at it, the complexity of the code and the performance costs associated with that make it something that I can't actually recommend. I try and, it's an important thing for me that if there's code that I'm showing in a video, it's generally either code that I have used or a variation of it, usually an improvement of code that I have used, or code that I would or intend to use. I don't want to be showing code that I don't think is a good approach. And so when all of the implementations that I can manage to put together are super complex and they don't have good performance, I can't sort of put together a video with that where it's a case of like, hey, here's this approach, when I wouldn't recommend using it. The monolithic one, it is easy to work with and it has really good performance. But the microlithic one, there is a lot of aspects about it that I do really like. And there is, it's something where I have long felt with, as I was implementing the different approaches, that there was going to be a good way of doing this, that there was going to be a way of doing this that had the performance characteristics of the monolithic style, but brought in some of the really cool aspects of the microlithic one, of those little having reusable actions there that can achieve multiple purposes. So I have been working on something for a bit. That's the idea is it's a hybrid. It's sort of blending a few different techniques, and I want to have that ease of use, that simplicity of monolithic, but that modularity of microlithic. But this is obviously something that there aren't other examples out there really for this. So I'm having to sort of a bit of trial and error, and I'm also wanting to, as part of this, improve the editor side experience for it, and so I'm trying to really push that so that it is here I want yeah, essentially here is the version that I would recommend doing. So that is something that I have been working on, continuing to work on. It's still a little bit away from me being able to actually uh, release that, provide a video on it, but I do want to be very much doing that because I think that sort of hybrid middle ground is something I feel that is going to be a really useful one to demonstrate sort of that middle of the road. Now, I may then end up doing a video on the microlithic ones, but it's going to be one that comes with a lot of caveats of I'm providing this as an example, and I really wouldn't recommend doing it. So it might end up being more something where I make the code available and the video is more sort of talking through it, not my usual sort of building the setup, because it isn't an approach that I really sort of recommend. And having worked with GOAP in quite a few different games, the monolithic style tends to work really, really well and gives sort of the results that I'm very happy with. So that's the reason with the microlithic GOAP. So what may end up happening is I release the code for it and a video sort of giving a bit of a orientation of how the code works, and then can go from there. So that is all the questions for this time, but if you do have other questions that you would like to submit for the next Q&A video, then there is a link in the description. You've got the link here as well. So submit your questions there and I will be able to provide some answers. Or if I don't know the answer, I'll look into it. So until next time, bye.